All right, this is the polar question from 2007. They gave us the graph of the circle and the cardioid. So first thing I did was just kind of color in what color the circle is in the orange and the cardioid is in blue. They gave us the intersection points, which most of the time on the FRQs, they will give you the intersection points. So 2 pi over 3 is one of them, and the other one is 4 pi over 3. So the first one says, let R be the area inside the graph of the circle and and inside the graph of the cardioid, so common area. Find the area of R. So what we're going to do is imagine cutting our theta wedges. So first we start at theta equals 0, which we'd want to stop at the orange curve. So from the integral from 0, and we're going to keep cutting to the orange curve until 2 pi over 3, and that would be R squared d theta. Remember, the formula has a half out in front, but we're going to use symmetry because we didn't find this piece right here. That will have the exact same area, so we're going to just multiply that by 2. And then switching to our next integral. At this point, at 2 pi over 3, we're going to start cutting to the cardioid. So from 2 pi over 3 to pi. And again, we're going to use symmetry. So there was a 1/2 in the formula, multiply it by 2 of the cardioid. Number 3 back in 2007 was a calculator problem. So you just pick up your calculator, put it in there. So 10,370. Part B. A particle is moving along the polar curve of the cardioid, has position x at t and y at t, where theta equals 0 and t equals 0 are the same. The particle moves such that dr dt and dr d theta are exactly the same. Find the value of dr dt at pi over 3. So we have that r is equal to 3 plus 2 cosine theta. We want to find dr dt, but they told us dr dt is the same thing as dr d theta. So all I have to do is take the derivative of this, so minus 2 sine theta, and we're going to evaluate this at pi over 3. And at pi over 3, that would be root 3 over 2. So negative 2 times root 3 over 2, which would then be root 3. Negative root 3. Okay, so how describe the particle motion? The particle is moving closer to the origin since dr dt is less than 0. dr dt is less than 0, r is greater than 0, and this is at theta equals pi over 3. Part C. For the particle described in Part B, we know that we have dy dt is equal to dy d theta. And we're again going to find the value of dy dt at theta equals pi over 3 and interpret the motion. Okay, so we start with r is equal to 3 plus 2 cosine theta. We know that the equation for y would be r sine theta. So for us, that would be 3 plus 2 cosine theta times sine theta. And again, this is a calculator problem, so we want to find dy dt. So I want to do dy d theta, and I'm going to take this directly in my calculator at pi over 3, and I get 0.5. So since this value is positive, so dy dt is bigger than 0. So we are moving away from the x-axis.